Now, when you're thinking about limit law problems, you have to remember that there's a big if in all of the limit law problems. If everything exists and works nicely, then you can break it apart. You might be looking at a problem like this, though, and you might say, okay, well, I can apply the limit as x goes to 1 to the numerator, right? The numerator would be -3 plus 4. Both parts make sense, so the numerator is just going to be 1. That limit makes sense. What about the denominator, though? Well, this denominator is x minus 1 as x goes to 1. So the inside piece, the limit indeed does exist. It's 0. 0 to the 2/3 power. Yeah, that limit exists. That's 0, right? But 1 divided by 0 doesn't exist. So the end answer is actually does not exist because the numerator is going to 1, the denominator is going to 0. That doesn't exist. However, if you're in most cases, you can really have just a ton of leeway to work well here. So as x goes to 6, we have the square root of 6 plus 3, that's 9, minus 3, over, let's see, what is that? 36 minus 1 to the 1/2. Well, this is 3 minus 3, so that's 0. This is the square root of 35. Well, it turns out the numerator can be 0 just fine. That approaches 0 as x approaches 6. And in turns out you don't even have to know what the function is. As long as I know as x approaches 5, the limit of f of x is 2, then I can do something like this. Using the limit laws, I can say, well, 3 is still going to be 3. This limit is going to be 2. And as x goes to 5, x is going to be going to 5. So we have something like 6/5 there.